Hello students, welcome to the another lecture of the course Engineering Chemistry. As we are ongoing with the unit 2nd organic fuels, so let us continue. Before starting the today's lecture, just the revision of the last class, what we have learned in the last class. In the last class we have learned about the liquid fuels, advantages of liquid fuel. Then after we will start with the crude oil or the petroleum. Mining of petroleum and refining of petroleum we have discussed in the detail in our previous class. Then we have started with the new topic, that is cracking process, in which we have learned what is the cracking process and the types of cracking process, in which we learn about two types of cracking process, that is thermal cracking and second one is the catalytic cracking. In our last class we have discussed the brief about the thermal cracking and the types of the thermal cracking. So today we are continuing with the catalytic cracking. In the today's class we will going to discuss about the advantages of the catalytic cracking, types of catalytic cracking, that is the fixed bed catalytic cracking and the moving bed catalytic cracking. So let us begin with the catalytic cracking. As we know that the cracking process is the conversion of higher molecular weight hydrocarbons into lower molecular weight hydrocarbons. So if this conversion is carried out in presence of some specific catalyst that may be silica and alumina gel or zeolite. So if the cracking process is carried out in presence of these catalysts, then the process is called catalytic cracking. Basically, the cracking process is the same in which higher hydrocarbons are converted into lower molecular weight hydrocarbons, and this conversion taking place in presence of catalyst, that is silica or alumina gel or the zeolite catalyst, then the process is called catalytic cracking. Clear? So the advantages of the catalytic cracking over the thermal cracking. What are the advantages? First is the no excessive external fuel is necessary. Sorry, the word excessive is missing here. No excessive external fuel is necessary as compared to the thermal cracking, because these reactions are carried out in presence of a specific catalyst. So the catalyst lower down the energy. That's why these reactions can carried out comparatively at the lower temperature. Second main advantage is the yield of the gasoline in catalytic cracking is higher side. It's about 70% of the raw material converted. That means in this process 70% of the heavy oil is get converted into the gasoline. So the yield of the catalytic cracking is high. Third one, the gasoline obtained by the catalytic cracking is of good quality. Why it is of good quality? Because it contains low percentage of olefins and high percentage of isoparaffins and the aromatic hydrocarbons. Later on in this unit we will discuss that the isoparaffins and aromatic hydrocarbons increases the anti-knocking properties of gasoline, which increases the quality of gasoline. Fourth advantage is the gasoline formed by the catalytic cracking has the octane number 80, which indicates good quality of the gasoline. So in all, the main advantages of the catalytic cracking process are no excessive fuel is required, yield is high, and the quality of the gasoline is high. So these are the main advantages of the catalytic cracking. That's why we opt for the catalytic cracking. Now coming towards the types of catalytic cracking. On the basis of the form of catalyst used, as we just now learned that which catalyst is used in catalytic cracking, silica alumina gel or the zeolite. So either of the catalyst use, its form matters a lot. If the catalyst used in the form of the pellets like this, if the catalyst used in the form of the pellets, then the process is called fixed bed catalytic cracking. While if the catalyst is used in the form of the very fine particles, that means in the form of the powder, then the process is called moving bed catalytic cracking. So what is the main difference between these processes? The main difference is the form of catalyst use. If the catalyst is used in the form of pellets, then it is called the fixed bed catalytic cracking. Second main difference, fixed bed catalytic cracking. And if the catalyst is used in the form of fine powder, then it is called as the then it is called the moving bed catalytic cracking. Second main difference between these two processes is the catalyst position. First difference is in the form of the catalyst, and second difference is in the form of the position of the catalyst. In what position catalyst used? If the position of the catalyst is fixed, then it is called fixed bed catalytic cracking. And if the catalyst is used in the form of the flowing liquid, then it is called the moving bed catalytic cracking. So the main differences are, first is the if the catalyst is used in the form of pellets and the position of the pellets are fixed, then it is called the fixed bed catalytic cracking. Second is the if the catalyst is used in the form of fine powder and this fine powder is used in flowing condition, then this is called as the moving bed catalytic cracking. So I hope it is clear what is the main difference between these two processes. Now let us discuss one by one each of the process. First is the fixed bed catalytic cracking. In this type of cracking, the catalyst is used in the form of fine granules or the pellets like this. This is the catalyst, and the catalyst is mainly alumina silica gel mixed with clay or zirconium oxide, and the catalyst is placed in the catalytic chamber. This is the catalytic chamber, and pellets of catalyst are placed. That means position of the catalyst is fixed in the chamber. Like this. So this is the fixed position of the catalyst in the catalytic chamber. The temperature of the catalytic chamber is 425 to 450 degrees centigrade. Now, what are the other components of this fixed bed catalytic cracking tower? The first compartment is the preheater. In the preheater, the temperature range is fixed at 425 to 450 degrees centigrade. Preheater is used to vaporize or to heat up the heavy oil charge. We know the cracking process is conversion of the heavy oil, that means higher molecular weight hydrocarbons are the heavy oil. Conversion of these heavy oil into lower molecular weight hydrocarbon and formation of the gasoline. This is the process what we'll be discussing in this fixed bed catalytic cracking. So first of all, the first chamber is the preheater, in which this heavy oil is preheated up to 450 degrees centigrade. Now these heavy oil vapors are passed into the catalytic chamber. In this catalytic chamber, the catalyst is placed in the form of the pellet. In presence of this catalyst and the temperature range 425 to 450 degrees centigrade and the pressure range 1.5 kilogram per centimeter square in this catalytic chamber. At this temperature and pressure in presence of catalyst, the heavy oil vapors are cracked and converted into the mixture of lower molecular weight hydrocarbons. So in this catalytic chamber, what reaction taking place? Basically, in this catalytic chamber, reactions are taking place in which various high hydrocarbons, HH is the high molecular weight hydrocarbons, are converted into various kind of lower molecular weight hydrocarbons. It could be methane, ethane, and so on, butane, propane, pentane. This type of large number of hydrocarbons are formed along with the some carbon particles. So the main reaction carried out in this catalyst chamber is the higher hydrocarbons. We know that the heavy oil components hydrocarbons are the hydrocarbons which contains 17 to 30 carbon atom. That means long chain hydrocarbons. So these long chain hydrocarbons are converted in presence of catalyst into the lower molecular weight hydrocarbons. So breaking of the molecule taking place in this catalytic chamber and the carbon particles are also formed. So these combination of lower hydrocarbons are now called the cracked vapors. These cracked vapors are now passed through the fractional distillation chamber. This is called the fractionating column. In this column, different type of hydrocarbons which formed by the cracking process are collected as per their boiling ranges. So we collect here from the gasoline part only, and the gasoline part or the gasoline vapors are collected and then passed through the cooler, in which cooling takes place and the gasoline vapors are now converted into the liquid gasoline, and this gasoline is collected and then passed through the stabilizer. In stabilizer, some amount of dissolved gases may be present in the gasoline. So in the gasoline stabilizer, the gases present in the gasoline are removed from the top and the gasoline is stored. So this is the process of the fixed bed catalytic cracking. So what we have learned or what we have discussed in the fixed bed catalytic cracking? In the fixed bed catalytic cracking, the heavy oil is cracked into the lower hydrocarbons, in which gasoline fraction we collect. So first of all, we passed the heavy oil to the preheater and heat the heavy oil up to the 450 degrees centigrade, due to which heavy oil get converted into the vapor form. Now heavy oil vapors are passed to the catalyst chamber, in which silica alumina gel plus clay and the zirconium oxide catalyst is placed in the form of the pellets. In presence of this catalyst and the temperature 425 to 450 and pressure 1.5 kilogram per centimeter square, these heavy oil hydrocarbons are converted into various type of lower molecular weight hydrocarbons, and these hydrocarbons along with some carbon particles are also formed. So all these hydrocarbons are passed to the next chamber. So these all mixture of hydrocarbon is called the cracked vapors. Now this is passed through the fractional distillation chamber. Now fractional distillation chamber is here, in which gasoline fraction we collect, cool down this fraction and stabilize the gasoline part. So this is the formation of the gasoline. But here we see the formation of the carbon particles also. These carbon particles deposited over the catalyst like this. So the carbon particles deposited on the catalyst, due to which the catalyst get exhausted or the spent. That means this catalyst surface is now not free for taking to catalyze the reaction. So what we have do now? To regenerate this catalyst, we pass the fresh air from here and supply of oil is stopped. So when we pass the fresh air from the upper side, the carbon particles reacts with the oxygen present in the fresh air and converted into the carbon dioxide, which is also a gas, which is removed. So the catalyst surface is again free. This surface is again free and the fresh catalyst is now exposed for the further reaction. So now this is again in its original form. So this is how we regenerate the catalyst. Again we stop the air supply from here and we can start the heavy oil vapors passing from this side. So this is the fixed bed catalytic cracking process. Now next is the moving bed catalytic cracking. As we just now discussed that the moving bed catalytic cracking is the process in which catalyst is used in the form of very fine powder so that it behaves as a fluid which can be moved in the gas stream. That's why it is called the moving bed catalytic cracking. Clear? The heavy oil, first of all, the heavy oil is heated in the heater and the vapors are allowed to mix with the hot catalyst. This is the preheater in which heavy oil vapors are heated. These heavy oil vapors are passed through this pipeline. This is the catalytic chamber in which catalyst powder is placed here. Here catalyst powder is placed. At the upper part of the catalyst chamber, cyclone is placed. Now catalyst powder moves from this pipe here in this direction and the heavy oil vapors moves in this direction. So the heavy oil vapors mixed with the catalyst powder and the mixture of the catalyst powder and the heavy oil vapors are passed through the next chamber, which is called the reaction chamber. In the reaction chamber, the temperature range maintained is the 500 degrees centigrade and the upper part of the reaction chamber cyclone is placed. So this is the first part which we must understand, that what is the procedure or what is the apparatus setup. So first is the preheater in which heavy oil is preheated. Second is the catalyst chamber in which catalyst is placed in the form of fine powder and this fine powder of catalyst flows down through this pipe and mixed with the hot oil vapors. Third is the reaction chamber in which in presence of catalyst cracking process is carried out. At the upper part of the catalytic chamber and the reaction chamber, there is the cyclone present. Cyclone is this unit is called as the cyclone. This moves round. So the reaction chamber is connected with the fractional distillation chamber, then cooler and then stabilizer. So what is the process? First of all, heavy oil vapors are passed through this pipeline mixed with the catalyst vapor. Both of these are now passed through this and reaction chamber. In the reaction chamber, reaction started. What are the reaction taking place? As we discussed that higher hydrocarbons, HH is the higher hydrocarbons, are converted into the lower molecular weight hydrocarbons in which methane, ethane, propane, butane, like this. Many of the hydrocarbons formed along with some carbon particles. So look at here, due to the high temperature, all the hydrocarbons are in the vapor phase while carbon is in the solid phase. This is the solid while all these are the in the vapor phase. So these are called as the cracked vapors while the carbon particles are in the solid form. Look at here. Here is the cyclone present. So when cyclone moves, all the gases, due to their lighter weight, gases comes in the central part and moves from this direction, all the cracked vapors, while the carbon particles moves towards the walls of the reaction chamber. So all the carbon particles moves down, right? So carbon particles along with the catalyst, we know that heavy oil vapors plus catalyst is passed through this reaction chamber, and in reaction chamber hydrocarbons converted, higher hydrocarbons converted into lower molecular weight hydrocarbons in presence of catalyst. So the catalyst is also in the form of powder, that means solid. Carbon particles are also solid. So two solid phases we have here. One is the catalyst and second is the carbon particles. These carbon particles deposited on the catalyst, and now the catalyst is, due to the deposition of carbon particles, is now called spent catalyst. This spent catalyst is in the form of solid particles. That's why moving towards the walls of the reaction chamber, while gases moves at the central part and removes from this pipe here. So cracked vapors goes down through the fractional distillation chamber, while spent catalyst collected at the bottom of the reaction chamber. Now the cracked vapors undergoes in the fractional distillation in this chamber, and the gasoline vapors we collect into the cooler, into the next part, which is the cooler, in which gasoline vapors are cooled down, and in the stabilizer the dissolved gas is removed from the gasoline and gasoline is collected over here. Now coming towards the spent catalyst. Now spent catalyst is goes down from here, and we passed the air through the air blower to the spent catalyst. So what reaction taking place? In the presence of oxygen, all the carbon particles deposited on the walls of the catalyst, these are the carbon particles, so these are converted into carbon dioxide, and the catalyst is again free for the reaction. So from here air blower, hot air is supplied. So this hot air, when comes in contact with the spent catalyst, the oxygen present in the air reacted with the carbon particles and converted into carbon dioxide. So in this pipe, carbon dioxide gas and fresh catalyst is again moves. Here cyclone is again present. So due to the cyclonic movement, carbon dioxide, which is the gas, moves towards the center and removes from here, while the catalysts are again collected here. So catalyst is in the form of the fine powder. So catalyst is again free for further reaction, and again this fresh catalyst goes down for the mixing with the hot heavy oil vapors. That's why this catalyst is again reused and regenerated, while the carbon dioxide moves towards the upward direction and removes from here. So that's all about the moving bed catalytic cracking. Again I am repeating the process for your revision. In moving bed catalytic cracking, first of all two things we have to remember. First, the catalyst is used in the form of the fine powder. Second, the catalyst is used in the moving position as a fluid. Catalyst is used in the catalytic chamber. Reaction taking place in the reaction chamber. The gasoline fraction is collected through the fractional distillation chamber. Gasoline converted into the liquid form in the cooler. And finally, in the stabilizer, pure form of gasoline is collected. So first of all, through the preheater, heavy oil vapors are preheated. Heavy oil is preheated and converted into heavy oil vapors. These heavy oil vapors are passed through this pipeline to the reaction chamber. Now, through the catalytic chamber, the catalyst vapors are moved and mixed with the heavy oil vapors. These catalyst powder and the heavy oil vapors are moved towards the reaction chamber, where in presence of catalyst at the 500 degrees centigrade, lower molecular weight hydrocarbon gases are formed along with the carbon particle. So, due to the cyclonic movement, all the lower molecular weight hydrocarbon which are in the vapor phase or the gaseous phase are moved in the central part and removes from here. So, all the cracked vapors goes from here, while the carbon particles along with the catalyst are in the solid form. So, due to solid form, these are collected to the bottom of this reaction chamber. Now, this spent catalyst goes from here and mixed with the air. Due to the presence of air here, the carbon particles are converted into carbon dioxide, and both of these, catalyst plus the carbon dioxide, now moves towards here, and carbon dioxide gas, due to the movement of cyclone, these gases pass through it and the catalyst is again reused like this. So, when the cracked vapors are passed through the fractional distillation chamber, the gasoline fraction we collect and pass to the cooler. In the cooler, gasoline vapors are cooled down and converted into liquid form, and this liquid gasoline is now collected to the stabilizer, where whatever the small amount of gases dissolved in this are removed and the pure gasoline is collected. So this is the moving bed catalytic cracking process. I hope you will be able to understand both of these processes now. Now, what we have learned today, we have learned the advantages of catalytic cracking, types of catalytic cracking, in which in detail we have discussed the fixed bed and the moving bed catalytic cracking. Now, today's learning check time. Pause your video for a minute, read the question and think about the correct answer. Why the quality of gasoline formed by catalytic cracking is high? A. Due to the presence of high amount of straight chain paraffins. B. Due to the presence of high amount of aromatic compounds. C. Due to the presence of high amount of isoparaffins and aromatic hydrocarbons. D. Due to the presence of high amount of olefins. Think about it and we will discuss its correct answer in our live class. Thank you. Take good care of yourself and keep enjoying learning. Keep smiling. Thank you.